All right, here we go. Hello, everyone. My name is Cy Venom, and I'm your host today on Containers from the Couch. I am joined by two AWS experts, and today we're going to be talking about how to better monitor your applications on Amazon EKS with some enhanced capabilities from CloudWatch, specifically application signals. Now, observability is one of my favorite topics on this channel. In fact, we recently had another episode talking about container insights in CloudWatch and how that works with EKS. And you all seem to really like that demo and that episode. So consider this almost a part 2 of that. Instead, we're going to be focusing more on the application monitoring side with application signals. But all of this stuff is deeply integrated, deeply connected. Really excited to get into this topic today and see what we can learn. So my two guests today are both going to be showing a demo. So double whammy, super excited for this. Hope you guys are as excited as I am back at home. All right, let's go ahead and start with my first guest here, Aman Agassi. Please introduce yourself. Tell us a little bit about what you do at AWS and what you're going to be demoing for us today.
Hey, hi, Sai, and hi, everyone on the live stream. Very excited to be here. I'm the product manager on the Amazon CloudWatch team, and I look at all products digital experience monitoring. So CloudWatch Synthetics, CloudWatch RUM, and now this newly launched and GA generally available service application signals that integrates all of this telemetry and offers you one pane of glass for your application monitoring. And I'm here to talk about that.
Excellent. Awesome. Aman, I see you're actually already sharing your screen. I'm just going to pull it up for like 5 seconds so folks at home can see what we're talking about, what we're going to be showing. We're going to be demoing application signals. This is, I think, one of the dashboards that you'll be showing us in more depth today. But folks, be sure to stay tuned because we have some in-depth demos into how all of this stuff works, how you can make your Amazon EKS clusters more observable, and how to dig into issues. Because as we all know in the cloud, if something can go wrong, it probably will go wrong. And so you better be prepared for when it does. Okay, thank you, Aman. Next, for my next guest today, Shiva. Shiva, tell us a little bit about what you do at AWS and what you're planning to show us today.
Yeah, thank you, Sai. Thank you, everybody, for this wonderful opportunity. It's good to be back to Containers from the Couch. I think this is the second time I've been here. It's wonderful to be back. So my name is Shiva Guruvarediyar. I'm a senior specialist solutions architect focusing on observability today. So today I will be we will talk about the application signals, which is recently GA'd, which is our curated APM solution from AWS. So that's what we are going to be talking today in the context of Kubernetes.
Awesome. Thank you, Shiva. Okay, so I want to take this way back to start our conversation today. Observability as a whole, it's an area where we have a lot of different competing solutions, open source and internally, and even the words to describe observability solutions. So we have application monitoring, traces, metrics, logging. We have different ways that we can retrieve this data. We have agents that users need to manage. All of these are topics that we'll cover today. But from a high level, observability, I think I see it as 3 pillars: logs, metrics, and traces. And you mentioned application signals is used for app monitoring. So where does it fall in those 3 pillars of observability?
Yeah, sure. Let me, hope you are able to see my screen. So let me quickly show this, right? So mostly today, most of the people, we are using microservices. And this is all bit complex in nature, right? So it's written in multiple languages, multiple programming platforms, and then multiple database types, whether it's SQL, NoSQL, and all those things. So as you mentioned, correlating all these signals, whether it is logs, metrics, and traces, it's going to be a tough challenge, right? So this is where we wanted to fit in by using applications performance monitoring, the way the usual AWS way of doing stuff. So with this one, how you can do this correlating these signals in one particular screen, without popping from one screen to another or one tab to another. So that's what we will be talking about today.
So what you've basically drawn in this PowerPoint slide is it's like a service map, right? But you had to flex your PowerPoint skills to create all of these boxes and arrows. But ideally, we would want to have something like this generated for us, right?
Exactly. Yeah. So this is where, if we can quickly share this one. So this is our, as you know, from containers perspective, for observability, you have a lot of options, right? You have AWS native options, you have AWS open source options like Prometheus, Grafana, and all those, and you have third party services available. So with this one, what we are trying to do is starting all the way from your instrumentation and collection, that is installing the agents. Like Sai, you mentioned, we have multiple agents earlier, right? If you want to send your traces, you need to install X-ray agent, and then if you want to send your metrics, you might be installing your CloudWatch agent, and then maybe for your logs, you might be using FluentBit and all those. So with this particular thing, we have something called a unified CloudWatch agent. So the unified CloudWatch agent will be taking care of all these three signals, that is metrics, logs, and traces, and then it can send it to the destination of this particular choice. That means your logs and metrics are going to be stored in CloudWatch, and then your traces will be sent to X-ray, right? On top of it, you have multiple visualization options. You can create your custom dashboards or metrics explorer, cross account observability if you're using multiple accounts. And also, like you mentioned, we have the enhanced container insights if you are using EKS or ECS. And then you have this particular layer called application signals. So which is what we are talking about today. So this is sitting on top of all these layers. So which is providing a correlated mechanism so that you can take all your signals like metrics, logs, and traces, and then you can do it from one particular place. And also the good news is you can integrate with synthetic canaries or real user monitoring, everything. So it is going to be a one-stop shop for all your observability needs. If your application is running in Kubernetes, just come enable this application signals, and that way not only you're going to see the different services, the service map, and all those things, but if you want to find the root cause analysis and all those things, you should be able to do it from this particular place.
I think this is something that we're going to have to see to believe, because when I had some of your colleagues on the show a few weeks back, they talked about container insights, which was just one box in all of those boxes that application signals overlays. So that solution seemed really powerful to be able to dive in, see traces, see what's going on, have a dashboard. But essentially what we're saying here is with app signals, we're still leveraging all of that capability, but giving folks the ability to build monitoring, workflows on top of that, and maybe something else that maybe you'll demo today.
Yeah, so that's what we wanted to get started on. For example, this is my EKS cluster today, right? And if I want to get started, it's as simple as just go to your add-ons, and then if you have this observability add-on enabled, and that's what you need to do it. That's pretty much it. You don't have to do a lot of things. So once you enable this, so behind the scenes, what it does is it will deploy this unified CloudWatch agent to your containerized environments. So that that is going to be acting like a vehicle, so that all your metrics, logs, and traces will be sent through this particular unified CloudWatch agent to the destination. So once you have done that, so under the hood, how it works is, today, if you're running EKS, ECS, and EC2, these are all the three computing platforms we are supporting today. And this is good news is we are going with open telemetry, which is the open standards. And using that, for Java, .NET, and Python today, you have the auto instrumentation feature. So even if you're running a legacy Java application, which is running for maybe a decade for now, and then if you enable this particular thing, you don't have to refactor your code to make sure it is observable, right? So once you created this, enable this application signals, using this application signals is enabled, it will be instrumented and then collected all these signals, that is metrics, logs, and traces, and using this unified CloudWatch agent, it will be stored in CloudWatch, that is metrics and logs are going to be stored in CloudWatch, and the traces will be stored in X-ray. And using that, you have the application signals console, which is like this today. Using that, you will be able to see all that particular information. So
I've got a question about the agent, Shiva. So we're saying this one agent can basically do all of these different observability tasks. how configurable is that agent? Let's say I want to start with just getting logs, like a Fluent Bit type setup. Is the agent going to honor that, or does it kind of just stream all of the data from our cluster to CloudWatch?
Yeah, it is basically like it supports all the three. And then if you wanted to have like configuration, as a matter of fact, inside CloudWatch, Unified CloudWatch agent, we still use or leverage Fluent Bit. So still, if you want to configure something and all those things are still supported. The only thing is like the agent fatigue, right? So earlier I need to use like 3 different agents for doing my collecting my traces metrics on logs, and today it is just only one vehicle that I need to worry about, right? But it's still like it is still providing all the configurations overrides that you wanted to do it. It is still supported.
Got it. So you can do it yourself if you want, but if you want to reduce the agent fatigue, or I like to call it cognitive dissonance of all the different pieces of operational overhead, just use the EKS add-on, which enables and installs the agents for you. Does it also maintain like the life cycle? Like, for example, if there are upgrades or you upgrade your EKS cluster, will the add-on help you manage that as well?
Yeah, so using that add-on, like you don't have to worry about the life cycle management. You can come over here, and then as and when a new add-on comes in, it is going to be automatically taking care of upgrading your CloudWatch agent, like Unified CloudWatch agent on all those. So it's basically the wrapper around it. So with that one, like your way of like managing this is going to be much more simpler.
Makes sense. Awesome.
Yeah, so once you enable this, like you can from here itself, we are giving a link. Just click on this one. So if I'm talking about a brand new cluster, so you will be greeted with this particular page, right? So here the platform you need to choose it. So this could be like EKS or like a custom Kubernetes platform or EC2, wherever your application is running. It doesn't matter, right? So from here, like I can choose my EKS cluster, like app signals demo. And then if I wanted to enable this, you have 2 different options. Either you can do it from this console itself, like the way I'm doing now, or if you have any kind of CI/CD pipelines, you can have like, you can take these annotations, basically just these 2 lines, and then put it in your CI/CD pipeline. And that way, like, it is going to be automated, right? So for just demo purpose, like, let me show you how we can do it from our console. So once you enable this console, all these particular services per namespace level, like you will be getting all that information. So then I can choose like which particular service I'm interested. So as I mentioned, like we are supporting 3 languages today. Java and Python are already GA, and .NET is in public preview. So all the 3 language options are available for you. So you can choose like whether, assuming this is a Python application, I just choose Python as a language, and that's pretty much it. So once you have done it, and then you just click on done. So this is going to be like enabling the automatic like OpenTelemetry agent for you, and then we call it as runtime monkey patching. So it is going to be sitting on top of your runtime to instrument and collect all these metrics and traces for you, and then using the Unified CloudWatch agent as a vehicle, it will be sent to the destination of this choice.
That's really interesting. How does this work exactly? Like, does your application need to use like a specific Amazon SDK or anything like that, or how is it able to hook into the runtime like that?
Yeah, very good question, Sai. So today, like we are following the OpenTelemetry, that is open standards behind that, like So using that approach, we are using the auto instrumentation feature. So as you know, like in OpenTelemetry, you can do it with both manual instrumentation as well as automatic instrumentation. We are leveraging the auto instrumentation feature. So that's what like we are supporting language by language. So today we are supporting all the 3 languages. So if you are running like a simple like a Java application, maybe based on Spring Boot, right? So that is automatically like supported by auto instrumentation from OpenTelemetry. So using that feature, like once you have done it, this particular agent will be automatically installed, and then it's going to be during the runtime. It will collect all the metrics for you, and then it will collect it and then send it for you. You don't have to do anything.
Huh. I didn't know that. That's pretty cool. By the way, we did get a question in chat from Rasan Khalsa asking, does this add-on support EKS on Fargate as well?
Yeah, I think today, maybe Aman, please correct me if I'm wrong. Today, we are not supporting Fargate. It is going to be like, it's in the roadmap, but it should be available soon.
Cool.
It does ECS on Fargate though.
Does support ECS Fargate. Got it. I have a feeling it has something to do with EKS Fargate not supporting daemon sets, not being conformant, that maybe throws some stuff into a loop. But that's interesting. Good to know it's on the roadmap though. Okay, Shiva. Now that it looks like we've got it auto instrumented, add-on installed, what's next?
Yeah, so once you enable all these things, right? So once you're coming over here in the CloudWatch console, in the left-hand side, you will be seeing this is something called application signals. So under which you will be seeing multiple options services, service map, SLOs, canaries, run. So everything bundled together, we call it as application signals, right? So when you're currently this is a hypothetical pet clinic application. So here I already configured some services for you already. So that's why you are seeing a lot of data here. So when you're coming for the first time in the overview tab, you'll be able to see the services by SLI status or service level indicator status. So service level indicators are the metrics that is coming out of your services, and then using that you can derive some SLOs. So Aman is going to be talking more into that in a bit. So after this we are supporting something called golden signals, right? So in the industry we call it as red signals or request, errors, and duration. So these are all the three things we are centering around. Wherever you are you'll be talking about, we'll be keep on hearing about this red signals the request, errors, and latency and all those information. So that is what we are showing here. How many the top services by fault rate, and then the dependency paths by fault rate. Because in a typical microservice environment, if your service is not performing, it doesn't mean that the issue is with only your service. So that could be some different services which are having a hit, and then by which you are indirectly getting hit, right? So using that as a mechanism, so we wanted to provide that dependency paths by fault rate also. So that is what you're showing here, top dependency path by fault rate. And then if you're coming down, so all the services which we just now saw, you can go ahead and then enable this application signals for these different services. And from here, it will be showing you the different services, what you are running it today, what are the different SLI status, if you already created an SLA on it, and then the service availability, and then what that particular application is called, and where it is getting hosted. So as I mentioned, today, EKS, ECS, and EC2 are the three supported computing platforms.
So Shiv, I've got a question here. I want to say that everything on this dashboard can technically be done without instrumenting the application code itself. You could get this data from purely the network layer, right? Granted, you have the health check set up to the right endpoints and that kind of thing. So what was the point of instrumenting the application itself? What level of detail does that provide us?
Yeah, that's a good question, Sai. So the point here is all these things, whatever you are seeing here, it's all coming very dynamically in nature. So all these things are coming from all the three golden signals, which is the metrics, logs, and traces. And using that, we are dynamically populating this information. So as and when your microservice environment, grows and shrinks, so you can keep on seeing what is going to be there at that particular point in time, without worrying much about your network configuration, or you had to go and do something on that. So those are all the things that is already taken care for you. So with that one, whatever your applications are running in your environment, be it EKS, ECS, or EC2, those information will be collected from here, and then with the availability and application level details.
Got it. So the reason I asked was because back in my Java days, I remember heap size and garbage collection was like a big issue, and it was like a very Java specific issue. So would we be able to get that level of insight in the dashboard due to the instrumentation, or is it something slightly different?
Yeah, that's a very good thing. We have roadmap items to take care of the JVM metrics. Maybe I will let Aman to talk more into that one. So especially for Java applications, as you mentioned, these JVM metrics are crucial, and people wanted to know more about what's going on with their JVM metrics, right? So that is something that is in our pipeline. So hopefully, very soon, you should be able to see those information as well, along with whatever we are seeing today.
Got it. Got
And
it.
I'd like to add, Sai, that with what you already get, like you'd be able to do a lot. We'll be able to see the troubleshooting experience here in a bit. One advantage that I would like to emphasize here is that all of this is brought now and at a service centric level. Like you'd have these different telemetry being collected, but there was no one place to find it and then correlate that in this particular point of view. And look at how easy it makes it for you to come onto this page and then immediately realize that what is the part of the application that needs my attention. And you do that by the SLIs that Seva mentioned, where you can just specify the condition on latency or availability that falling below that particular threshold, it's going to show up in red here. So it really offers a really good way to triage all of the problems that your application is facing, and then dive into each problem to get a solution out of it.
Makes sense. Makes sense. Yeah, I love to see that this kind of stuff is in the works or already available, because I think that level of application monitoring is going to provide a lot of value to,
Yeah, and
everyone.
I would love to show that on my screen here, like how you can go and find some of these root causes. So if this is your service screen where you have the list of services which are auto discovered by a discovery server, you can click on this service which is currently stating that there's a problem with latency.
One second, Aman. I want to ask you a question. SLI versus SLO versus SLA. Indicator versus objective versus agreement. What's the difference?
So service level indicator, the SLI, that's the instantaneous snapshot or instantaneous status of how this application health is. So if you have specified that your latency beyond 2000 milliseconds, it's a bad experience for your users. So falling short of that, exceeding that threshold is going to instantaneously show it as unhealthy SLI. These SLIs aggregated over a period of time, let's say a month, can be transformed into an SLO in the sense that whether you have hit your service level objective. So you define whether you want availability over a period of a month to be always upwards of 90%. And an SLO will be able to tell you that achieving that SLO would mean having that availability greater than 90% for that period of time. And that would be the aggregation of the SLI status over each period.
Got it. Got it. And you know what? We have a comment in chat which might help us actually walk through a realistic scenario here. So Rasan wants the ability to get email alerts for when pods crash. Now, Rasan, I'm going to challenge you here a bit and say you probably don't want an email alert every time a pod crashes, but when your application becomes unhealthy. So there's another layer there, right? Of let's not just look at pods running, but whether end users can access the application. Because Kubernetes is self-healing. One pod going down out of 10, maybe not too big of a concern if it's able to quickly recover and fix itself. So can you map that goal, Aman, to what Rasan is asking here of what would we do? Now let's put aside Fargate support for a second. If we wanted to monitor pods on EKS, what would we actually create an SLO for?
So you would define your SLO on the service operations that are the most crucial. So for this pet clinic front-end service, I know that registering an owner of a pet is a very crucial operation. So I would define an SLI on latency and then convert that into an SLO to see how am I doing on a monthly basis or on any period of time, a week or a day even.
And if we don't meet it, how do we alert on it?
You put alarms on that. So I can, in order to create an SLO, I would define a service level object. I would choose a service for it. Let's say the front-end service. I would choose an important operation, that is this get operation on this endpoint.
How did it figure out all those operations for the front end? Where did it get that from?
That's the beauty of auto instrumentation, that you're not specifying what services and operations they're running on. All of this is auto discovered once you have the observability add-on for EKS.
So it's automatically pulling, maybe there's an open API spec document or somewhere or something like that, and it's just pulling the APIs that's cool. Okay.
Yeah.
Yeah. That's
And
very cool.
and to finish this flow, you define a condition that we've been talking about, let's say on availability, evaluated over a certain period, and then you would be able to track that for your availability of 100%, like you'd want to be 100% available, but what that's for all practical purposes, are you able to maintain at least 95, at least 99? And that's what you would specify as a goal here, and get a alarm every time you are either close to that or breaching that. So there could be an alarm on your attainment goal, or it could be on your instantaneous health. All of that is under the purview of this feature, even for warnings. So if you want for the threshold of a 30% approaching the error budget close to 30%, then that can generate an alarm too.
Okay, so SNS, that's the primary way most of these things work for setting up notifications.
Yes,
so
so
from
that's
SNS,
how,
you can do whatever you want. You want a text message, you want emails, whatever you want. You can
that's how
configure.
Rasan can get an email out of this once we have this for EKS on Fargate. Right now, you can do it for EKS, EC2, and ECS,
Excellent.
and any other platform using the custom method. I want to also demonstrate, like once you've identified that something's wrong, how can you go about like troubleshooting that, which makes the other important half of this experience. So once I land on a unhealthy problem, I click on that service. I land on this overview page, which is now centered on the particular service I'm triaging. I'm looking at the same level of aggregations on how many operations are healthy versus unhealthy, for all the dependencies that the service is talking to, how are my fault rates trending. Again, giving you a sense of what is it something that needs your attention. But to go even granular, I click on this service operations tab, get the list of all the operations that we had specified this SLO on. And then for the selection of operation, get out of the box these matrices of availability, latency, and faults and errors on a time series without having to set them up manually. And once I see that the latency of this operation, it's spiking very often, I can study this graph and even interact with it by clicking on a spike, and then load all of the related telemetry in this diagnostic pane over here. So for the point that I've found particularly worrisome, at 1910 UTC time, I can see the trace which is correlating, which is firing up and collected just around this time, and click on that to look at the trace view of this request. This shows that the Nginx proxy is talking to the front end service, which is making a call to the customer service, which ultimately is calling an external API for the payment gateway. And that is something that's seeing a 50% fault rate, which might be leading to this high latency. And if I scroll down, I'm able to see all of the calls that were made, and then click on the failed call to load what is the additional information here, uh, perhaps what are the exceptions, and look at this stack trace to find what the problem was that led to this failure.
Okay, so yeah, we can see clearly what's contributing to most of that delay is these failed calls.
Potentially.
And what happens? Does it just keep retrying until it passes, and that's why the request worked, but it just took a while?
Yeah, that's when you would have to like look at this stack trace to figure out what this problem is. But this has already narrowed your search from all of these independent services down to this one call made to the payment gateway, which is seeing this fault.
That's pretty cool. Yeah, this is like the fancier auto-generated version of that slide Shiva was showing us earlier, but
Exactly.
without any manual work needed. It figured it out on its own with the instrumentation.
And one more thing is, Sai here is like, as you could see here, what Aman is showing. So here you can correlate all the three signals, right? If you see the left-hand side, you are seeing your metrics. and in your right hand side you have traces as well as logs. So you don't have to jump around multiple pages to go ahead and then see. The correlation is available from one particular place.
Yeah,
Right.
I even saw in that trace there was a button there for open and CloudWatch log insights, so you could just forward directly into that interface if you're more comfortable navigating logs in
Right.
that interface as well. So
Right.
that's pretty neat how it ties all of these functionalities together. So it's not like there's just this one solution on an island. It builds off of the other APIs that exist in CloudWatch. That's what you want to see. If we always tout that we're building a single pane of glass dashboard. Well, this is what that would look like. So that's pretty cool.
And if you're not able to see, like if you perhaps did not see a correlated trace collected for the same timestamp, you'd want to see other matrices and logs to figure this problem out. All like the way that integration works is by going to using the different tabs here. So I know my system is an EKS service. It's running pods and nodes. Uh, I can also see the breakdown of this latency by the different nodes or pods to figure out whether it's a problem that's affecting all of my infrastructure or it's some components that are being affected by it. And looking at this data here, it looks like the spike in latency was contributed more by this first node than it was by the second. So to look deeper into it, I can click on the view dropdown here, and I can view all of this data in greater detail in container insights that your audiences must be already aware from the talk last week. And you can surface infrastructure level data on how your performance is trending infrastructure wise. You can look at your CPU utilization, like how's memory, how much space is left on the disk, as well as the network, and correlate that same point of spike with some of the spikes here to figure out whether or not uh, running out of memory is the issue that you're now seeing high latency on your requests. And all that without having to carry over the context from the last screen to here. These filters are automatically applied, and this data is filtered for the node that I was looking at, which was having a high latency during its operation.
Got it. So high level, this feature, what personas in a company are we targeting with this? Are these like Kubernetes SREs? Are these like the management teams? Are these developers? Who's accessing these interfaces?
With this site, it's anyone and everyone who's using telemetry to figure out what's the problem with their applications, and then how to fix them. So you rightly said it's the SREs, it's also the DevOps, but it's also the backend front end teams who are responsible for overseeing the performance of their operational health of their applications. And this is where they would come to see what needs their attention and then find correlated to telemetry to get to the bottom of stuff.
Got it. Now, Aman, as a product manager, I'm guessing you have quite a bit of input on the type of things that we prioritize and build in this dashboard. How do you decide what we prioritize, what we're building?
So this really flows in from our end customers. We are constantly in touch with the stakeholders which are going to be using the service in production, and we have enabled many of our customers such as JPMC, Ancestry, to use these solutions for their production environments, and then we are collecting inputs directly from them. We hear about their problems, and that's what goes into our quarterly prioritization plan, and that's when we get a design solution for it, commit to a date, and start cracking at it.
Awesome. Yeah, it's good to get that insight. For folks that are watching, maybe Rasan wants to open an issue and say, hey, can you prioritize the Fargate stuff? How can folks get involved?
So folks can definitely get in touch with us. We have a mailing list for application signals feedback. Let me help you drop that in the chat where folks can reach out and get in touch with us and register their valuable feedback.
Yeah, if you provide that, I'll drop a line here so that folks can access it. Okay, Aman, I'm not positive if you were done with your demo. I think we were promised some rum earlier. Maybe not the kind of rum that I'm thinking about, but is there anything else you wanted to show in the demo today?
Yeah, I would, uh, since you have brought up real user monitoring, the
Oh, that's what rum is. Oh, okay, got it.
yes, during the day it is. And what we have here is the integration with synthetics. The like in this, since we are in the service view, you should be able to see what canaries are hitting this service, so that whenever there's this increase in duration for a canary run, on whenever there's a drop in the success percentage, you can tie it back to which service it's coming from. So in the same view on this tab, I'm able to see that the duration is spiking for this point of time around 1929 UTC, and clicking on that, I am able to obtain the precise canary run that led to this failure. And I can use all of the run artifacts, such as the screenshots collected during the canary run, to the logs or the har file, to understand what order these requests fired up and which ones of them failed and for what reason exactly.
Oh, wow. Yeah, so you're getting a more complete user experience,
Yes.
not just, the API calls, but exactly how they're interacting with the application. So I know a
Yeah.
lot of times for intermittent issues, you can't really figure out what's going on from the API calls itself. But yeah, the more data you can get, the better, I presume. So that's pretty cool.
Yeah, and then the client pages is where you'd see all of your rum data. So the web vitals that you're tracking, so that your customers are not frustrated, they are having the best experience. You see all of that trends here, and on this page, you against any of the spikes or unusual anomalies, you click on again, interact with this graph, get all the relevant events, and start debugging right here.
That's pretty cool.
And that's the RUM dashboard for you.
Very nice. Very nice. All right. I think that was a lot of material. I almost want to go back and watch some of this stuff already. For folks that are watching, if you have any questions or want to get in touch, now's a great chance to drop a comment live, or if you're watching the recording, drop us a comment in the comment section below. Appreciate any and all questions, and I'll make sure you get a response from the team here. Now, Aman, as kind of a closing statement here, well, tell us what you're showing here, but also maybe tell us one or two things that you're most excited for on the CloudWatch app signals, or in general, the roadmap.
Yeah, this is definitely a great year for observability at APM. We are excited about the support for JVM matrices, which is definitely going to bring all of the telemetry from your Java machines. We are also excited about enabling this for more platforms and languages. .NET is our latest adventure, where we have gotten as far as a public preview that should be generally available. We'll be supporting Node.js soon, and for platforms, we are down as much as ECS. And the next thing is we are already in the serverless territory. So the next piece and milestone for us is going to be Lambda. So this service is coming for more. We are trying to bring more and more customers and under the fold of who can benefit from this service and this kind of observability with
Oh
CloudWatch.
man, Aman, you were ready with that answer, ready to go. I guess you ask a product manager at AWS what they're excited about, and it's everything. It's a lot of things that are coming down the pipeline. That's awesome. Shiva, any closing comments? Anything you want to share with folks? Ways to get involved, or things that you're working on, samples, anything like that you want to share?
Yeah, sure, Sai. So yeah, this is pretty much interesting product. Like, and I would suggest the customers to try it out. The good news is, like, even I used to be a developer for so long. Like, it's pretty hard to get the metrics, logs, and chases out of it. And also the good news is, like, you're not tied to one vendor. Like, because this is open standards, open telemetry, and auto instrumentation, right? So as a developer, I know the pain if somebody wants to observe it, their services, like, they don't want to refactor the code and all those. So using the auto instrumentation that open telemetry provides, following the open standards, and then correlating all the signals from one particular place, and also like bridging the gap between like your application layer with APM solution like application signals, and in your infrastructure layer like container insights, we are bridging the gap with a lot of particular all this in tooling, right? So with this one, like you should be able to see whether you are a developer persona or like an SRE persona or DevOps persona. It's going to be like adding a lot of value for you. So I would like suggest you to take a try and then see like whether it's going to be fit your bill. It's going to be like easy to for you to get started, especially if you're starting with EKS. So just enable that add-on and then just a couple of clicks and then you should be good to go. Please try it out and then please share your feedback. We are willing to get your feedback from you, what you're seeing from here.
Awesome. By the way, guys, it's time. I'm going to start talking about reInvent basically every time I go live now. It's about 3.5 months away. For folks that are watching that might be at reInvent, can we expect to see content around this at reInvent? Maybe not. Maybe we don't have specifics just yet, but are we going to be featuring a lot of this stuff at reInvent as well?
Yeah, sure. We are having like some lineup of items. So this is also going to be like feature and our upcoming feature that we are adding it, like the .NET support and the various things that we are going to be doing in the next 3 months. All of them are going to be featured in the reInvent.
Okay, awesome. Well, hopefully I'll see you both there as well as our viewers at home. If you make it out there, we'll see you in Vegas. All right, folks, that's all we've got for you today. Appreciate all of you for joining us at home, and especially to you, Aman, Shiva. Thank you so much for this awesome demo-focused, detailed episode. So much to absorb here. I think I am going to have to go back and watch some of this myself because I think we just covered so many concepts so quickly. Thank you so much for coming on the show.
Thanks for having us. Thanks for mediating this, Sai.
Absolutely. Folks watching at home, be sure to subscribe to Containers from the Couch on YouTube to see more episodes like this. Also follow us on twitch.tv/AWS. We'll catch you next time. Bye.
Bye.
Thank you.